Hi, everyone. Hi. Welcome to Global Azure Day 3. I'm Harald Finnbakken. I'm a part of the Norwegian .NET user group who is organizing this event. If you were listening in before, this is the second session of today, and I'm very pleased to welcome our speaker, Petter. Petter,
Hello.
you take it away.
Yeah, thanks for having me. My talk today is about the Windows Virtual Desktop, and I'm going to go through some use cases and some reference designs to go along with those use cases. Just to kick it off, a little bit about me. I'm a senior consultant at Lillevik IT. I've been in the IT industry since 2003, so I barely missed the Y2K issues. I've always been an all-rounder, but the last few years, my focus has shifted to Microsoft 365 and Azure. So that's me. Just quickly, a little bit about what is Windows Virtual Desktop. And in essence, it's RDS as a service, or Remote Desktop Services as a service. It gives you the main infrastructure components in an RDS environment delivered and maintained by Microsoft as a service for free. I say free because you have to pay licenses and, Azure consumptions for some of the components in Windows Virtual Desktop. So just to visualize what you have to be maintaining and what Microsoft has will be maintaining. If you see that all the stuff on the right side is managed by Microsoft, and they provide all this scaled and highly available for you. And the only thing you have to consider is all the stuff on the left side, which is basically the session hosts. If you're familiar with RDS components. The session hosts and everything revolving them, imaging, profile, policies, and all that stuff, while Microsoft will be handling the broker service, gateway, load balancing, all that stuff you really don't want to be managing yourself. And Windows Virtual Desktop is also the only way currently to get Windows 10 multi-session, which is quite awesome because traditionally we would be using RDS environments when we have server operating systems. But now we can have a client-side operating system, which is a little more handy, a little more user-friendly. I guess some would say they are more bloated, but then again, more user-friendly. So that's kind of a great thing, I think. So in order to have Windows Virtual Desktop, you will need some bare minimum stuff like Azure AD or Microsoft 365 tenant with Azure AD in it. And you need, of course, an Azure subscription and some licenses. If you are using Windows Virtual Desktop with Windows 7 or Windows 10, you would be only needing the Microsoft 365 Business Premium or higher licenses. That would be the E3, the E5, A3, A5, and the F3. Some would argue that maybe F3 is not higher than Business Premium, but anyway. You can also license this using the Windows E3, E5, A3, and A5 licenses. And you might notice that these are all Microsoft 365 licenses. You can't buy a single license like you would on an on-prem environment. And if you're running Windows Server operating systems for your session host, you would also need to have RDS CALs with software assurance for your operating system of choice. Additionally, you would also need a traditional Active Directory that is synced with Azure AD. And that can be either traditional domain controls using AD Connect, or you could also be using Azure AD domain services if you don't already have a traditional Active Directory. So with that out of the way, let's skip to some use cases. And the first one is also the most basic one. It's I just want a desktop in the cloud, and I have nothing from before. So why would you want this? Well, it's great for convenience. You could connect to your desktop from anywhere in the world and with any device. And if you're, for example, if you're out traveling and your device or your laptop or breaks, gets stolen or anything, you can just continue working on your phone or your tablet, or maybe pick up another cheap laptop, and you would have your desktop already in the cloud, and nothing really has changed with that one. And it's also great if you're working with multiple environments. For example, if you're a consultant doing most of your work with clients in their environments, but you also have your employer's environment, then you can have a Windows Virtual Desktop, for example, with your employer, and then use your local device with all your clients. And of course, it's also a great case for testing, demoing, and doing proof of concepts. And the way we would do this is you set up your users in a Microsoft 365 tenant, including licenses. We deploy Azure AD domain services, and then we deploy Windows Virtual Desktop. There's also a few little steps in between there, like you also need a Azure subscription, like I mentioned before. And also when you deploy your Azure AD domain services, you would also deploy a virtual network. But these are the main steps in this use case. And as you can see, there's really not a whole lot. And the design for something like this is quite simple. You have your Azure AD on the left side, and you have a sync down to Azure AD domain services, and you have your session hosts that are authenticating towards Azure AD DS. And on the right side, you see all our endpoints, our clients, which could be Windows clients, Mac clients, iOS, basically anything that can run HTML5 browsers as well. And they connect through the internet to the Windows Virtual Desktop control plane, which Microsoft provides control planes in all over the world, basically. And the control plane has all the main infrastructure components like web access, gateway, the remote desktop broker service, and all that. So your endpoints and your clients would connect to the control plane that is physically closest to them, so to provide the lowest latency, and then the control plane connects to the session host and acts as the gateway there. And as you can see, the session hosts are not directly connected or exposed to the internet, so that's also a great thing about this kind of setup, is that none of your services are really internet exposed. And kind of the same use case or scenario, but in this case, we already have AD Connect, so we have some services from before. And when we have AD Connect set up from before, it would be much the same, but we will be skipping the Azure AD domain services because we already have a traditional AD that is synced to Azure AD. And in this case, we would need a connection between the session hosts in Azure and the domain controllers. This can be VPN, or you can also use express routes. And optionally, in this case, you would have a domain controller in Azure, really just to lower the latency in logons for your session hosts. But you would still need your VPN or express route, the connection between the domain controller on-prem with AD Connect and your domain controller in Azure. And as you can see, the setup is still not really advanced. It's quite simple. We have the VPN between our on-prem environments and our Azure environments. And you have the domain controller on-premise doing user sync with Azure AD, and the session hosts are doing authentication towards that domain controller over the VPN connection in this case. You could expand on this design, as I said, with an optional domain controller in Azure, and you could also consider having some sort of central storage of the user profiles in Azure if you are using multiple session hosts. So the next use case is if you want to lift and shift your entire on-prem to Azure. Your entire on-prem will then perhaps include some RDS services already. And a couple of reasons why you would want to do this. If you have older unreliable hardware or just hardware that is out of support, so if something breaks, it can't be replaced easily. Or if your company is relocating from one office to another and the new office don't include any place for on-prem servers, or simply if you want easier disaster recovery than you can achieve with your on-prem environment. So in this case, you would start by establishing a connection between your on-prem environment and with Azure, and then setting up Windows Virtual Desktop with some fresh new session hosts, and then test all those session hosts to make sure that they are working with your on-prem environment, because in this case, all the servers would be on-prem and your applications running in Azure on the session host, and they need to be working. Then use something like Azure Migrate to lift your servers up to Azure, and after making sure that the Windows Virtual Desktop works after migration, you just tear down whatever old RDS environment you would have. So this is the kind of setup that I would do from starting here before we are lifting our on-prem. It's kind of the same that we had in our last use case. I've added the Azure files for central storage of user profiles. And in this case, we are not setting up a domain controller in Azure from on beforehand, since we will be lifting the domain controller with all the rest of the on-prem stuff into Azure. And as I said, this is where you are before the lift and shift, and hopefully after you have done your lifts, your setup will look something like this. Quite the same, just all your servers running in Azure. But what if you want to do a lift and shift, but you have to take it slowly? And this is maybe if you have larger environments that are not suited to have a lift and shift within a few hours or a weekend or something like that, then you can use Windows Virtual Desktop as kind of a setting it as a primary tool for your users. And if you do that from the start, then they will probably not notice that much of you moving servers in the backend. So as we see here, establish Windows Virtual Desktop as you did in the previous case. Instruct your users to use Windows Virtual Desktop as their primary tool. And it's really important that you set the expectations right in this case, because since Windows Virtual Desktop is living in Azure and your servers are all on-prem, then Windows Virtual Desktop will be slower at first because of the added latency between Azure and your on-prem environment. But once this is all set up, you can migrate servers and applications at your own pace without really having to bother your users that much. So this is basically the same as the start of our previous lift and shifts use case. You have your VPN set up between the Azure environment and your on-prem, and all the session hosts are doing authentication and application access over that VPN connection. But somewhere in the middle, when we're starting moving servers, it can look something like this. In this, we see that we have moved some servers. We have established a domain controller in Azure to reduce the logon times. And we still have some servers left on-prem. But in the end, the hope is that you will end up with something like this, where all your on-prem is gone and moved to Azure. And that way you can decommission all the stuff you have on-prem. So that's the lift and shift use case. But what if you just want to work efficiently from cheap hardware and preferably have the same user experience from any device out there? And you can use VMware Desktop as a fully fledged workstation using existing mobile devices, something cheap like the Raspberry Pi, or old and redundant unused hardware that you have laying around. If you're going with the Raspberry Pi way, you might want to take efficiently out of the equation, because you would be forced to work in the browser only, and that might not be efficiently, but still every mobile device you have or old hardware would be nice to be used for working efficiently from rather cheap hardware. And a couple of things to consider in using this in this use case is that you would want to have a short path, and you want to have personal session hosts. And this is because the keyword here is efficiently, and you don't have to have short path, you don't have to have personal session host, you can use pooled. But if you want to be working efficiently, then you need short path to have that reduced latency between your end device and your session host. And you also want to have personal session hosts so that someone other than you on your session host isn't hogging all the resources, because that is one of the things that might happen when you're using pooled session hosts. You have 10 users on one server, and maybe 1 or 2 users are using 90% of the resources, and the rest of the users on that session host will then have a bad time and not really be working efficiently. And this is a example of how you might be setting up such a use case. It's a bit more advanced than the last design, and that's mainly because we are using short path, preferably. And as you can see, we have some endpoints on the left side, and they are using a VPN connection to Azure, so that they have a direct line of sight from the endpoint up all the way until the session hosts, because that is a requirement if you're using short path, is the direct line of sight. So in this case, you would have your endpoints that are on-prem. They would do the initial connection through the internet to the control plane, and then the connection to the session host would be using the VPN connection and using short path. The rest of the stuff is kind of the same that we have had in the other reference designs. We have a domain controller with AD Connect or Azure AD domain services that's providing sync up into to Azure AD, and providing the traditional Active Directory so that session hosts can have their authentication. We also see that we have an instance of Azure files that we are using for central storage of all the user profiles. In this case, we also could have endpoints on the internet, as you can see on the right side. It would function pretty much the same, but since there's no direct line of sight between the endpoints and session hosts, you can't use short path, so you will see some increase in round trip time, latency, and bandwidth, really. I've seen cases where, with using short path, the round trip time and latency has been cut in half, and bandwidth has been increased by tenfold. So short path is really great for gaining that extra performance or reducing all that latency between your endpoints and your session hosts. So what if you want to offload workloads from your local machine so that you can free up some resources on it? This is also a great use case for Windows Virtual Desktop because you can run heavy applications or workloads in Windows Virtual Desktop instead of running them locally, and thus increasing your productivity because you're freeing up time waiting for renders or exports or something like that. And one example is if you're doing, for example, video editing, you can do all the editing part of the work on your local device. And then when it's time to render the finished video, you can do that in Azure and then still continue working on your local device instead of twiddling your thumbs waiting for the render to be complete. And a couple of things that you need to consider in this use case. Here you would preferably publish apps and not desktops, just to have that more fluent workflow for your end users. And that in publishing apps, they can kind of look like they are locally installed, even though they are running in Azure. So it's really user-friendly for the end user in this case. And again, preferably use personal session hosts instead of pooled session hosts, and also have short path enabled or use it whenever you can. And also for this, please remember to use fslogics for your central profile storage. That way your only benefit isn't just that you have central storage, but with fslogics you will also decrease the logon times because it's a much faster technology. And the design for this is actually the exact same as before, because in the previous example we were using desktops, but in this case we are using published apps, and the design doesn't really change much. It's just a matter of publishing the apps instead of the desktops. So let's move on to our next use case. That is if you just want a management environment for your Azure infrastructure as a service that you already have, of course. And traditionally, you would set up a single Windows server for management with a public IP that doesn't have modern authentication, so you can't have MFA, and one that scales kind of poorly. Now you could swap out Windows Server for Linux Server, of course, but you would still have a public IP and no modern authentication, and it's the same for scalability, really. And here is where, if you use Windows Virtual Desktop as your management environment, it's a lot more scalable. Your session hosts aren't exposed to the internet, and the logon to Windows Virtual Desktop is based on modern authentication, which means that you can use all of Microsoft 365's security features like MFA, conditional access, identity protection, and so on. Plus, this kind of environment can live side by side with any Windows Virtual Desktop that you have for your users. And so instead of having your single server for management that you have to either size up or scale up, you have Windows Virtual Desktop that would not only scale up, but you can also scale out with more session hosts if you want. And you can also kind of silo it in on the same way that you would with a single Windows Server management. And in this example, we have one user Windows Virtual Desktop for your main users, and then you have your management Windows Virtual Desktop for your IT department, for example. And you also have your main Azure Infrastructure as a Service down on the right side here. And here you can see that the management Windows Virtual Desktop and the user Windows Virtual Desktop is completely separate. There's no traffic running between them. You could if you want, but there's really no need for it. But they are both using the same domain controller with AD Connect or Azure AD DS. They're using the same for authentication. And that's really the only thing that they are sharing. The session hosts in management Windows Virtual Desktop only have access to the management of all the servers in your Azure Infrastructure as a Service. And the user Windows Virtual Desktop part only have application access to your Azure Infrastructure as a Service. And as you can see, they are sharing the same control plane, but you can split them up in different workspaces, for example. And besides, it doesn't really matter that they are sharing the same control plane because that's not managed by you, so you don't have to really worry about it. And yeah, as I stated, this can live side by side, fine. And your IT guys can have both their management via Windows Virtual Desktop and the user Windows Virtual Desktop in the same client as well. So they don't have to do any changes on their local device if they are switching over to the user Windows Virtual Desktop. But what if you just want a traditional remote desktop environment and you are starting from scratch? This is kind of the ideal situation for a tech guy like me. You have nothing. You're starting from scratch. If you're building Azure infrastructure from scratch, I would recommend using the hub and spoke topology. And in this case, you would consider your Windows Virtual Desktop as traditional RDS, but siloed in and living on its own little spoke. The reason why I would prefer the hub and spoke topology in this case is that it makes it a whole lot easier to lifecycle manage your environment, and it also increases security and the visibility of all network traffic and services and so on. And the design in this case is a bit more advanced, but it's like I said, this is the fun stuff for a techie like me. You have your hub, which is where you will have all the main services in your Azure environment, and all services that are shared between spokes. For example, in this case, you have a domain controller with AD Connect or your Azure AD DS that is shared between all the spokes. So we can put that in the hub in this case, and the session host in the Windows Virtual Desktop spoke can communicate with it. And all the service in spoke 1 and spoke 2 also can communicate with it, but they don't necessarily can communicate between one another. So in this case, you would have spoke 1 and spoke 2 will be living in their own little world and not having any communication between them. But you can if you want. And in this case, you would then, even when you spoke 1, the services there are out of their lifetime, you can just tear them down without having to consider all the other stuff around. For example, if I'm going to take down spoke 1, I would not have to consider the Windows Virtual Desktop environment because they are living in its own little spoke and its own little world. So this is a great way to lifecycle, as I said, your lifecycle manage your environment, and could also save a little bit of money on common resources like the Azure Firewall in this case, and VPN connections, for example. In this design, all of our spokes can use the same Azure Firewall, and they can also be sharing the VPN connection to our on-prem environment, either by having some sort of connection between the VNets, or by using VNet peering, which is perhaps the most simple way of doing it. So that's the most advanced design, I think, but it's also the most scalable one and sensible one, if you ask me. And then lastly, we have the I just want a locked down environment. And this can be a lot of reasons. For example, if you have some highly secured applications that need a tighter set of security rules, you can use your group policy objects to lock down your session hosts even further with session time limits, clipboard redirection, printer redirection, camera, microphone. All that can be disabled using either group policy objects or the settings in Windows Virtual Desktop. And you could also make use of a quite new feature that is in preview, which is called the screen capture protection, which enables you to block out any screen capture applications on your end user device, for example, print screen or any recording software on the endpoint. And this makes a great case if you are having applications in your Windows Virtual Desktop that you don't want your users to have on their local device, for example, because of security issues or concerns. But at the same time, you can provide access to that application from anywhere in the world and on any device if you want to. And the design is pretty much the same as some of the simpler designs that we had earlier on. You could go without the short path, so you could skip the VPN connection, but as long as you can have it, I think you should have it. So unless you really want to cut some costs, you should have your VPN connection so that you can utilize the short path feature. And as like I said, the screen capture protection should be enabled. That's a setting that you do in Windows Virtual Desktop, not a infrastructure thing. So enable it, and it'll block and detect and block screenshots, screen share, and others. For example, if your users are using Teams and sharing their screen, it would just simply black it out. So some final thoughts from my side. Windows Virtual Desktop has a lot of use cases. I have covered some of them, but far from all of them. And they have a lot of use cases, but it also has a lot of configuration options. And some of the use cases can be configured in multiple ways. So, and some of the use cases can also be configured in the same way. So there's a lot of different use cases, a lot of different configuration options. It really depends on what you want to have from Windows Virtual Desktop. And it's not always ideal, but in most cases it'll do the job. There are use cases where perhaps Windows Virtual Desktop isn't the best, but it will still do the job. And for a lot of companies, it's basically free, since if you have your Microsoft 365 from beforehand, and maybe you even have your Microsoft 365 business premium licenses already in place, then all you would have to be paying for is the compute consumption for your session host, or maybe some Azure ADDS or central profile storage with Azure files. And there are a lot of features currently in preview that will improve the service immensely, or are already doing so. And from its first GA, when it became general available, it has gone through a lot of change. There's a lot of new features that has come to Windows Social Desktop. So if you only had a look at Windows Social Desktop when it was first released, I would highly recommend you checking it out again. So because there's so much features there that are new and has improved the service quite a lot. And lastly, use reserved instance and other cost savings methods. They are a lot more flexible than you might think. And perhaps do set up your production environment, take a look at how it works and how your performance is, and scale it rightly, and then go along and do reserved instance, for example. And with that, we are a little ahead of time, but we are actually at our questions part. So Harald, is there any questions for us?
Yeah, perfect. Thank you. Let me go through a couple of the questions here. First one off is there anything you should consider regarding to the VM sizes? Any preferred sizes, and what would you think around sizing of the VMs?
Well, first and foremost, if you're setting up a demo environment or a proof of concept environment, I would probably use the B series because of the pricing. But in a production environment, I would not be using the B series because they kind of feel a little bit sluggish, if you know what I mean. And also, if you're packing your users quite tightly on your session host, then consider actually going for the VM sizes that have GPUs in them, because that will offload your CPU quite a lot. So yeah.
Great. But I think that brings us to the, well, maybe relevant to the next one, but do you have any experience around the latency round trip to the Norwegian Azure data centers and VVD? And could you potentially replace your development laptop by using VVD?
Yeah, we are actually using it at my current employer and quite happy about it. And the latency is quite small. It doesn't bother you at all. I mean, it's still a remote desktop services, but in practical use, it's really not noticeable at all. And if you could replace your development laptop, I think so. Yeah, just be sure that you're using not the B series, because we actually tried that with our devs, having Visual Studio running in Windows Social Desktop. And what we experienced with the B series is that tab completion, for example, it just didn't work. But as soon as we switched to a D series VM, then it was all fine and dandy.
Nice. So then you can potentially outsource your local hardware and mostly virtualize it.
Yeah.
Next question, just scrolling through them. Have you encountered any tricky scenarios with VVD, like publishing older legacy apps, or anything particularly tricky that you want to comment on?
Actually, I think the one I had the most problems with is the Edge, because that is it's a little bit different than using just publishing an exe file. But no, not really. The most tricky scenario, or what we struggle mostly with, is actually when you're publishing applications and the user click the application, it's waiting for it to start, but the logon time is a bit too long, so they get they click again, and hopefully they'll work this time, but it takes a little bit of time to log on the first time you kick off a published application. But I think that's the most trouble we've had so far.
Yeah, Perfect. So last question that is in for now. If you're already using Citrix, could you use VVD or combine it? And what value would that give them?
Yes, you could combine them. Citrix is one of Microsoft's partners and I think always have been in regards to Windows Virtual Desktop. It was a launch partner. So Citrix is value adding to Windows Virtual Desktop, if you could call it that. So we have your Windows Virtual Desktop in like the foundation, and you have Citrix building on top of that. And yeah, definitely you could combine them, and it would value add. I have to admit that I'm not that familiar with Citrix, so exactly what value it would give you, I am not sure. But yeah.
Yeah, perfect. I think that's it for the questions. Thank you so much for the session. It was super.
Yeah, thanks for having me.
Yeah, thank you. Then we will have a short break and we'll start up again at 3 o'clock. So just stay tuned if you're listening in. And again, thank you. And I'll put on the break in between. Thanks, everyone. See you later.
Yes. Bye.